Okay, hello, good morning, good evening, good afternoon for everyone who's watching us today. Thanks for joining. My name is Ramy AlDamati. I am a solution architect in Kaspersky lab and blockchain influencer, and I have my colleague Pavel. He's the Kaspersky blockchain security group manager. So today we will talk about how blockchain technology has become an integral part of the business process in the enterprise. Discuss some use cases where distributed ledgers deliver their best value, and we also take a look at the threat landscape and corresponding cybersecurity measurement tailored for the blockchain-based systems, and provide recommendation on how to make your project secure. Because based on our global experience, we figure out that having the technology does not mean that your business is secure 100%. You still need to have some additional security services or engagement, as we will explore in this BrightTALK sessions. So starting from the DLT or distributed ledger technology definition, it is a database that exists across several locations or among of multiple participants. The design of most of the companies that they have a centralized database that live in a fixed location or multiple locations as a centralized for a single point of failure, which is the main problem for the existing system. However, the distributed ledgers is designed to be a decentralized, to eliminate the central authority or intermediate to process and validate and authenticate the transactions. So enterprise using the DLT technology to process, validate, authenticate transactions or other type of data exchange between multiple enterprises. Typically, these records only stored in ledgers when consequences that have each by involved parties. So all the files in the distributed ledgers are time-stamped and give a unique cryptographic signatures. And all the participants in the ledgers, the distributed ledgers, can view all the records in the data. So this technology will provide a verifiable, auditable history for all the information stored in the particular dataset. Now, the DLT technology, it is a way to manage the data and the business process more efficient and secure compared to the existing system that have a lot of gaps and problems by design, and it needs a lot of enhancement. So DLT represents a decentralized database where the records are immutable, cannot be changed, cannot be tampered, while the data transactions are automated and trusted. And blockchain is an implementation of the distributed ledgers. Okay, so there's two types of blockchain technology. Is a public and enterprise. So almost everyone knows blockchain as a technology that related to the cryptocurrency, like Bitcoin, Ethereum, and other cryptocurrency details. This, what we called it, is a public blockchain, which is an ideal solution for cryptocurrency, with it is anomaly by design and 100% a decentralized database that populated the digital economy to the new era, and it changed the way of people interacting between them by eliminating the third-party intermediate. But the public blockchain is different. It's called a private or enterprise blockchain, which need to be identify the user itself and the role for this user, and what is the access for this user in this blockchain series. So the technology accelerates the workflow and add a new performance level to multiple issues in the business, like the workflow, supply chain management, production management, and many others of these that being used in different use cases in our time best. So we can see today multiple use case implementation for the enterprise blockchain, like digital identification, verification, insurance industry, complex risk coverages, and some health industry also engagement, real estate, patient consents and health data exchange. Also, we can see it in the retails, consumers goods, and the supply chain management and the government. We have a lot of use cases that can be discussed and explored for the enterprise blockchain or the private blockchain. The biggest benefit for it is to reduce the cost, improving the authentication of the transparency of the data for all the participants. This serves the foundation of significant scalability for the business, but also create a certain risk that must be considered, and we will discuss some details about these risks and the landscape for them. As we can see in 2019, and according to Gartner's CIO agenda event, that this distribution and services sectors will lead the retail and the professional industries, with spend with more than $642 million on the blockchain, and more than 6% of responding have already implemented the blockchain in their system and going on to implement it within the 2019. So as you can see, also the manufacturers and the resource sectors, also driven by skirt and the process of manufacturing industries. So the spending on this industry mainly, it will be more than $653 million, which is almost 9% of the industry investors. Now, also another important part in this technology, which is the finance part, or the financial sectors, which is mainly where are the banking, the securities, the investment services, the exchange systems. So they are investing with more than $1.1 billion, which is more than 18% of the implementation of the private or the distributed ledger technology solutions as of 2019. So, as we can see also, by 2022, the enterprise ledgers, in most of the cases, like enterprise, will be proving a solution to organize business process that will scale and reach up to very good level or rapidly growth. And according to IDC Worldwide Blockchain Forecast, 2018 to 2020, but the total spending will be more than $12.4 billion by in 2022. So in 5 years, the annual growth rate will grow almost more than 73.2% for this technology in the business, which is a rapidly growth as we can see. So as a conclusion, you can see that the blockchain has stopped being just a buzzword that we keep hearing about it in the media or in the internet or some articles or something. But there is a lot of multiple solution for large companies being already implemented and start using it in big entities like Visa or some another big names we can see. And we always, every day we hear in the market that there is a new implementation or a new considerations in a specific technology to use the blockchain or the hyper ledger technology. So as initiatives of the Hyper Fabric, which is an open source initiative that most of the leaders contribute with that. We will go now to define the Hyperledger's concept or the technology itself. So you can see that Hyperledger terminology is an umbrella project for open source blockchain and tools and platforms. So, this have been founded in December 2015 by Linux Foundation, and a lot of industry giants being joined this contribution, like IBM, Intel, SAP, Vera, to support this collaborative development of the blockchain-based distributed ledgers in order to support multiple industries like information technology, banking, logistics, transportation, finance, manufacturers, even the IoT, or even integration with the AI for the future technology as well.
And hello everyone, my name is Pavel and I'm a blockchain security group manager at Kaspersky. We have said a few words on the information security for blockchain. Now let's take a closer look on our so-called holy grail of information security, the CIA triad, confidentiality, integrity, and availability, and how it's applied to security model in distributed ledgers and specifically in Hyperledger Fabric. So when we talk about the confidentiality, the solution that Hyperledger offers us is designed to be permissioned, so an access to information is limited. This is achieved through attribute-based access control and built-in Hyperledger Fabric encryption. As for integrity, blockchain by design uses cryptographic hashing to ensure that the ledger itself remains tamper-proof. The same concept applies in Hyperledger, so all the transactions are cryptographically signed and the blockchain is used to keep them tamper-proof. And as for availability, the decentralized nature of blockchain makes it difficult or even impossible to disrupt its applications with denial of service attacks or distributed denial of service attacks. But there are still some things that may go wrong in this model. So encryption cannot really protect your data from corruption if it's caused by configuration error and software vulnerabilities. And data itself also can be vulnerable to spoofing and tampering when there are network security breaches. And intruders, of course, they can obtain an access through targeted attacks or social engineering when there is not enough endpoint protection. A chain code or a smart contract. The chain code is actually a name for smart contract in Hyperledger. It itself can contain some inconsistent or vulnerable business logic. So the problems can also be not just technical. If there is a breach in a system responsible for business processes, there are also potential direct consequences for your business, such as financial losses, reputational risks, failures, client claims, and maybe even some regulatory infractions. So to sum it up, the fact that blockchain itself is immutable, it really brings risk to a bit of higher level comparing to standard centralized applications. Okay, let's take a look at the typical enterprise blockchain threat. So we look at the distributed ledger threat landscape as a kind of three-layer model. It consists of three layers: infrastructure layer, business logic layer, and applications layer. For the infrastructure, this is where servers and Docker containers and all the environment live. Typically, Hyperledger Fabric relies heavily on use of containers, such as Docker or Kubernetes. Containers, they run on top of operating system, and a common software such as message brokers and databases is used to provide interoperability between components. These components are, of course, have their own vulnerabilities. So for you, it would make sense to make sure that versions of software you're using doesn't really have those vulnerabilities. I will give you a few examples a bit later. The business logic layer. This is where your smart contracts and chain code live. The Hyperledger currently supports Go language as the main language for development. The SDK software development kits for Java and Node.js are available, and Python SDK is also on the way. The chain code and consensus are written by people which make mistakes. One of the important points relevant to distributed ledger applications is that they are quite prone to non-deterministic behavior. That means the chain code must be executed by every authorized node in blockchain in exactly the same way. There are some points that you or your developers must be aware of when writing chain code. Also, blockchain, of course, is a living system. It's not made in stone. So that means that some built-in mechanisms such as rights management and privilege management, they should be periodically reviewed and updated. And most of the time, it requires escalated privileges, which when used incorrectly, may also introduce some vulnerabilities to the system. And finally, the applications layer, which is, from our perspective, is represented by clients and applications interacting with distributed ledger via APIs and SDKs. Those are typically end-user applications, and they're by nature vulnerable to all kinds of human-related threats, such as phishing, social engineering, or malware, as well as development threats, of course, such as introducing vulnerabilities within the source code. Okay, here are a few examples of actual threats and vulnerabilities for each case. For applications, as I mentioned earlier, end-user applications and endpoints are subject to malware attacks, such as viruses, advanced persistent threats, malware, etc. Human factor also plays quite an important role in terms of social engineering attacks, especially when we are dealing with users with high privileges or so-called super users who are able, for example, introduce changes to consensus and authentication mechanisms. For the business logic layer, I already mentioned an importance of determinants. An example of vulnerability introduced by non-determinants is that you can introduce timestamps from your chain code. I will give you details a bit later about this kind of vulnerability. The business logic layer is also responsible for chain code interpretation or compilation. And you should remember that compiler itself is also might be vulnerable. For example, take a look at the Go language 2018 14.801.809 vulnerability, which leads to an authorization bypass and reduced performance or even interruptions in resource availability. And infrastructure, it's built on generic software widely used across enterprises. For example, Docker has some vulnerabilities. I gave an example here. This vulnerability allows an attacker to obtain super user access to a host, so to an actual physical server where the Docker container is run. So, how do you deal with all these threats? Well, first of all, for endpoints and applications, use any kind of endpoint protection, such as antivirus software. You may also need to think on performing application security assessment. There are some generic methodologies, such as OWASP, and also penetration testing might be used as an ultimate tool to assess your level of cybersecurity. For business logic layer, make sure your chain code is implemented in a deterministic way, and that compiler you're using doesn't have known or maybe at least critical vulnerabilities. And for infrastructure, think on how to protect your nodes. Make sure your container's host is configured properly, including means of remote access, such as SSH. Your firewalls are up and running. And finally, run vulnerability scan from external and internal network perimeters. Speaking of distributed ledger, this might be a bit tricky in terms of execution, since most of the time your distributed ledger is running across several companies, which of course may have different security policies. So that's something maybe you need to negotiate with your partners in business. So talk to them on some common policies, pretty much like you do when you're negotiating consensus mechanisms. Okay, I promised to give you a few words on importance of determinism and to give you an example how it's applied in chain code. This is a bit of technical, but don't worry, I'll try to make it as simple as possible. And if you don't understand anything, just get in touch with us and we'll give you a few examples also. So, generally, your chain code, it should avoid the situations when the result of the execution of chain code might be different between nodes. This will result in inconsistency, and in some edge cases, the transaction that is called in a chain code might never be executed. So common scenarios that involve such behavior are implementation of timestamping from chain code and use of random number generators. So what's wrong with the timestamping? Well, if your chain code is implemented so that it puts a timestamp on transaction from chain code itself, then if the time is not synchronized between your nodes, or maybe there is even a delay in execution of chain code between nodes, this will obviously result in different timestamps produced by every node. So this transaction is inconsistent, and this will most likely never end up in ledger, since of course it is inconsistent between nodes. And the solution here is simple and obvious. Just don't use timestamping in your chain code. You should supply your timestamp from end user application. So this is your application on the user that generates timestamp, not the chain code. Okay, so how we at Kaspersky can help you on with your distributed ledger. We gave you an overview on threat landscape and applicable to enterprise blockchain, and also we gave you several recommendations on how to mitigate those threats. So you've probably done already something. You implemented your distributed ledger, and now it's time for you to deal with cybersecurity issues. How we can help you here? Well, we actually provide all services necessary to give you a top-scale cybersecurity for your enterprise blockchain environment. Our service, called Application Security Assessment, fits for both applications and business logic. We can provide a penetration testing for your applications and infrastructure. And finally, we can provide a chain code audit that will not just reveal vulnerabilities, but we also address specific issues such as determinants issues and undeclared features. As an independent third party, we also can confirm that your chain code is implemented exactly as outlined by business process. This is very important since in enterprise blockchain, you're dealing with a number of companies, a number of business partners. So you may want to think of some third party which will provide an independent review for your chain code. And of course, finally, we can offer protection for all your endpoints, including workstations and servers, as well as container environments. So, these products and services, they are comprised of a solution called Kaspersky Enterprise Blockchain Security. This solution is designed specifically to protect decentralized environments and to make sure your blockchain is protected against all kinds of threats. And finally, we called our presentation to blockchain or not to blockchain. And we think here that the answer is yes, to blockchain. Just think a bit about your cybersecurity, your applications, business processes, and infrastructure. And thank you very much for your time. Now we are ready to answer some questions if you have any. Okay, I see the first question here. How does public blockchain preserve anonymity when it also gives transparency of transactions to everyone? That is a very good question, although it's a bit out of the scope of this presentation, but we will answer it anyway. The public blockchain, if you take a Bitcoin, for example, it gives transparency on transaction, but it doesn't really tell you who are the parties of transactions. In fact, there are some services out there in the blockchain which are called tumblers or mixers. They are specifically designed to hide the traces of parties in the blockchain. So still, even if everyone knows your address at blockchain and on Bitcoin specifically, it doesn't really disclose your identity, your person. Some crypto exchanges, they do implement KYC or know your customers procedures. But there are also always ways to just pass it. So anonymity doesn't really equal here to transparency of transactions. But thank you for the question, a good one. The next question. Hello, as I understood, Hyperledger operates on an execute order validate model. So it allows Hyperledger to tolerate some non-determinism, and one can specify the orderer to accept not 100% endorsements for all peers, so that the transaction can still be validated, even if some nodes don't run the same results due to timestamping. So I don't really understand the example of chain code determinism as a limitation. Could you please clarify? Again, very good question, a bit technical though. So if we're talking about Hyperledger, it does implement the model for execute order validate. And it is true that the endorsement can be configured so the way that not necessarily all nodes will accept the transaction. But ultimately, it depends on how you configure your endorsement policy. So if your endorsement policy assumes that every node must accept this transaction, then this will create an issue. So that's basically a kind of application security assessment, during which we also review your endorsement policy. And I gave an example of chain code and the timestamping specifically, just to make it kind of simple and obvious for the audience to understand the importance of extra precautions, so to speak, for chain code development. It doesn't really sums up to a problem of determinism. There are some other issues as well. But again, very good question. Thank you very much. Okay, another question. How would you recommend one finds the right expert for chain code, smart contract, application validation, other than hiring Kaspersky? How does one determine the authority of the expert? Well, there is a big community out there. BitcoinTalk.org might be a place for you to look at. So I guess you address the community. Just look at the karma of specific people at Bitcoin Talk and you will understand what they do. Also, there are some specific services on the internet. You can Google them easily. I'm not going to name them, but you can find a few that offer such services. Okay, Ramy, can you answer this one? In your opinion, is the current public blockchain, such as Ethereum, are ready to develop a lot of projects? Explain, please.
Yeah, definitely. Actually, Ethereum blockchain technology, actually, it is maybe most reliable platform at the current time to deliver such projects, because their developer, their people who work on it, they build it for the project. They build it for the sequence or the requirement for the helping the technology and helping the delivery for it. Now, for implementing some use cases, it needs to be defined for each project. Each project needs to run in some sequence of like questionnaires, what is the proper use case, what is the requirement, to define the proper blockchain platforms like Ethereum or others. So definitely, usually when blockchain implementers go with this part, they start selecting or answering some questionnaires in order to understand the requirement and define it, then go and define what is the proper platform for them. Okay, and fine. Now another question there is, how can we build enterprise solution on a public blockchain for added transparency and trust while managing the risk of the code breaking when the public blockchain is updated? Yeah, this is a very valid point and question. Usually when you want to implement a project or a public blockchain, the main constraint during the testing or implementing the project is with whom you are dealing with in the development part, with whom you are working with, the solid of your source code of the project, the workflow, the platforms. So some security assessment need to be done, or code review. It's a must to be done if you don't have an in-house developers and you deal with like third parties. Even the in-house developers, sometimes they don't follow the compliance or the regular development procedures in their implementation, because they care about delivering project in a manner of time, but they don't care about the securing of the code. So maybe a small mistake will make it a vulnerable in the smart contract or something. It will go to the blockchain with some vulnerabilities. Now, okay.
Okay, I have a next question here. If a virus or ransom attack is introduced to a blockchain, for example, in a smart contract or inside a transaction, what prevents it being distributed to every node on the blockchain? Well, depending on the configuration that you have done in terms of permission for your blockchain. For example, we already mentioned options for endorsement mechanism. Those are actually the limitations mechanism that allow to not to implement the virus or some other malicious code in the blockchain. If we take the Hyperledger, for instance, again, there was a question about it which mentioned execute, order, validate model. The trick with Hyperledger, when you, let's call it, deploy a chain code in the Hyperledger Fabric network for the first time, it doesn't really get into a ledger the moment you deployed it and it reached consensus. So it gets executed by the nodes first, and nodes produce the results, and they end up in kind of comparing results with each other. So that's the extra measure that may help you to prevent the malicious code run in the blockchain. Also, again, talking about Hyperledger, the chain code itself is executed within the Docker container. So unless we have some known vulnerabilities or zero-day vulnerabilities in container environment, the code execution itself is contained. So theoretically, it shouldn't harm your physical machine when executed. But yeah, of course, this is the issue that you need to think about when you're deploying chain code to your infrastructure. There are some measures on protection, but they're not like 100% silver bullet. I mean, the Hyperledger, seriously, they've done the great work introducing the cybersecurity measures in their development. But still, we think there are some points of improvement for this great products. Do you have some specific examples? Yeah, Ramy, take it from here.
Okay. Another question that you mentioned, how does proof of stake work in Ethereum and Hyperledger, assuming both protocol use the consensus mechanisms? Now, in the consensus mechanism is different from different platforms like Ethereum, Hyperledger Fabrics, or the Corda. So in Ethereum, it is working based on mining. The mining there is based on the proof of work. So if you do your job as miners, you will get the rewards and you will generate the block over there. So it's like a ledger level and capability and so on. Now in the Hyperledger Fabric, the consensus there is based on the board understanding of the consensus that allow multiple approaches, which is like transaction levels or engagement level or let's say, as an example, the node that assume different roles and tasks in the process, it will reach to this confirmation of the record. But compare it to the Ethereum, the role and the task of the node participant to reach the consensus are identical. So the different platforms have different way and approach. Even in the Corda, R3 Corda, it have also specific understanding of the consensus, like notoriety nodes, the transaction levels, and some other consents over there. So every platform have its own mining rules, or let's say consensus area to approve. Now, another question, can you please share some of the surveys you meant to decide which type of blockchain to choose? Actually, it is not a survey, it's a questionnaires. Usually, the project manager or of the platforms will ask you to implement. If you wish, you can just communicate with us. We will share with you some examples. These questionnaires ask you that how your network is look like, how is the databases look like, who's the parties, who's the what type of infrastructure you have, what is the most important part is what is your objective to implement the use case, what is the use case that you want to reach to it, because it's difficult to change all the business together at the same time at the same level in one project for blockchain. You need to do it in a gradual, and you need to do it in a POC phase or testing phase to check if it is do the job for you or it didn't do the job. And the most important part that most of the people that answer it, they mention that I need to increase the security by implementing the blockchain. Fine, you will increase the security in a specific level, but still you need to consider the third-party integration or the existing infrastructure integrations or the people who will implement it. Security. This is a security factor also need to be considered, as we mentioned in our presentation, in the infrastructure level or application level or different level. So the security measurement is very important as well.
I'm just going to add a few words on the question regarding the consensus, specifically the proof of stake or proof of work mechanisms. The Hyperledger, it supports pluggable consensus mechanisms, meaning I'm pretty sure you are able to introduce the proof of work consensus mechanism in Hyperledger. It's just, I cannot really think of any practical use for it. So BFT or PBFT consensus mechanism is supported out of the box in Hyperledger Fabric. And for myself, I think this is the most convenient way. But again, if your business needs requires you to use the proof of work mechanism Hyperledger, I'm pretty sure you can do that. And also, we have a question here. Do you have some specific examples of cybersecurity issues in Ethereum or Corda that is different from Hyperledger Fabric? Yes, in fact, we do. If we're talking about Ethereum, the smart contracts in Ethereum, they are built using the Solidity language. And there is actually quite a few known incidents with Ethereum and Solidity smart contracts. The most known one is probably the DAO incident, which led to a hard fork of Ethereum. So you might want to Google for that if you want to know more details. It's pretty famous one. So people lost a lot of money on that one. And that was actually the vulnerability introduced by one of the developers in the smart contract, for the smart contract. Speaking of Quora, this presentation is not really about Quora, although we are considering preparing one targeted to Quora. But you can easily find the Quora threat model. It's quite similar to what we have done in application to Hyperledger. I cannot really name any known vulnerabilities out of my head for the Corda at the moment. But you see our names on the screen and just get in touch with us. And I'm pretty sure we will be able to give you some examples. Also, the trick with all the enterprise blockchains is they are not yet that widely used for the vulnerabilities to become famous. I mean, it was a big thing with DAO because people lost actual money and the amount of money was huge. But again, with the enterprise blockchain, there are incidents, but they're not that famous. And we have another question here. Does operating system vulnerabilities, for example, Android vulnerabilities, can be used to track the transactions or gain an access to the blockchain? The question is a bit general. So if you would have given me some examples of vulnerabilities, I would probably be able to give you a more specific answer. But to answer this specific question, the answer is yes. Technically, you can use all kinds of vulnerabilities to track the transactions and gain an access to blockchain. So if we're talking about tracking the transaction, I'm assuming you want to ultimately you want to know who is the party of transaction. And in this case, some simple Trojan horse virus or some phishing bot can be used as a means to track your transaction and finally to disclose your identity. And in terms of of gaining access to the blockchain, again, I'm assuming that you want to have a privileged access and get a certain role in the blockchain environment. And that also can be done by just literally stealing your credentials through some Trojan horse virus. So that would be my answer. Again, if you have any more specifics, get in touch with us on the emails there on the screen, and we'll give you our feedback, of course. Okay, I just wait a couple of minutes. Maybe we can have some extra questions. Okay, we have a question here. Can you give an example of any actual use case or implementation? Ramy, can you pick this for me?
Yeah, sure. In our region, actually, there is a lot of use case implementation. Especially, I can mention a couple of them. One of them come to mind now is mainly in the health care industry. The blockchain can transfer the healthcare enterprise concept to increase the quality of the care for the patients in multiple ways, with the new ecosystems that will be proposed and the new business model. So this healthcare information that is stored in a centralized database and some other people that might have access to them, it will be transferred to a different way. Blockchain, it will decentralize the healthcare information, increase the database availability and the efficiency, the transparency, and the trust. So your record will not be accessible by everyone. You don't know who are accessing to yours. And this has been already implemented by help of big giants as IBM in our region, either in UAE or in other areas within the ecosystem of the hospitals. And some other use cases, mainly also in the government. Mainly, it can be implemented in different way in the government, like issuing the identifications of the people, register the property in the landlord department, the selections, enforcement of the laws, because once the government implemented, it will protect the personal information of their citizens and maintain the trust between them and their identity. It will not be compromised for everyone, and it will be have specific validations. So scaling the compliance complicates life for the government administrators. Also, it will be helped there. So there is a wide range of services it can be delivered, and it can also reduce the waste of time in the process, the procedures, the abuse of the records, some maybe mistakes when you register your kid in the vital public records or something like this. All of these will be changed, and there is many of organization or government now is being implemented, especially in Dubai, because they have the vision to be almost all their government by 2020 a fully blockchain, or at least have blockchain technology in their premises. Also, the law enforcement, the asset registrations, fraud prevention in the banking. There's many of use cases. It is implemented in the region, and maybe it is part of implementation process even.
I see the question here. In Ethereum platform, there is a transaction with gas. Is there a transaction in Kaspersky Enterprise? Okay, just to make it clear, we are not developing blockchain enterprise blockchain solution at Kaspersky. We have developed the solution for security for such platform. So we don't have an in-house platform for blockchain. We provide the security for blockchain-based solutions. And the next question is, do you support R3 Corda? Yeah, we are aware of R3 Corda existence, and we're planning to add it in the near time. So if you have some specific business requests, again, get in touch with us. You can see an email on screen, and we'll see how we can help each other. Which platform is used in Kaspersky, Ethereum or Hyperledger Fabric or Photos? At Kaspersky, we actually provide the smart contract and chain code audit for Hyperledger Fabric and Ethereum. And I'm going to give the answer for the upcoming question as well. What programming languages do you support? For Ethereum, we obviously support Solidity as the programming languages. For Hyperledger, as I mentioned in my presentation, the built-in support is for Go language, so we support that one. And obviously we support Java and Node.js and Python as well. So literally we are language agnostic. It doesn't matter for us. We have experts for any kind of enterprise development programming language. It's a good thing actually for Hyperledger Fabric that it adds more and more support for programming languages. The Go language is good, but it's not that popular comparing to Python, for example. So that brings the entrance barrier a bit lower for enterprises.
So the question also is coming now, also answering another couple of questions, that is our target customers. So mainly we are, as we mentioned, my colleague Bafel, that we are not delivering a platform for a blockchain. We are supporting the security on the top of the platform. So any customers who have this technology in their premises, or they are willing to implement it, or they are in the POC phase, or they have like an integration working with IBM, Microsoft, Amazon platforms, and they are doing their job to implement it with use cases, defined use cases in their environment. Our role will come before they execute and run it in a production. So we need to be on the top of the project to review the source code before it is executed and go to the blockchain, to review the smart contract details, review the source code of the programming language if you have in-house or third-party programmers. So this is mainly our role of engagement. Even sometimes if you get compromised from your network, we have our incident response and threat hunting teams that they can help also in such engagement for investigations or sharing intelligence and help you in this type of levels of engagement.
We have not really a question here. Yes, in Ethereum we use smart contract, and in Hyperledger Fabric we use chain data. Yeah, we understand what you mean. Actually, it's just the name. So the chain code is called the smart contract, and the smart contract is called the chain code. It's the same thing. It's just the Hyperledger uses chain code and Ethereum uses smart contract. But it's absolutely the same. We have another question here. What is your expertise in application security assessments? A very good question. We actually have experts at Kaspersky who provide security services for all the major vendors such as Oracle, Google, Apple, I mean, you name it. There are public case studies that you can get familiar with. And it's really not just about running some vulnerability scanner. What makes us different in terms of delivering the application security assessment, we actually do it by hand. So there are living people who are looking at the source code of your application and chain code, and they're trying to figure out what your code does, what it does not, and what vulnerabilities and some undesired features may be introduced. Of course, we follow the best practices in these scenarios, so all kinds of web application consortium and OWSP testing guides, so we adhere to that. But we still have our own in-house expertise, which I think is best in class, honestly. Thank you, good question. Okay, we have, as far as I understand, we have 4 minutes left. So we are waiting for more answers from you. I really didn't expect that many answers, but I'm happy that it makes a presentation interesting. So it's good to see that you're interested in this topic. Okay, I have a question here. What kind of protection you offer for Docker-based solution? We at Kaspersky, we have a solution called Kaspersky Hybrid Cloud Security. This is the set of products designed to provide the protection for cloud deployments. We support public and private clouds. That is why it's called the hybrid cloud security. And we also provide the protection for Docker containers. So actually what I'll give you just a few examples. So we are able to detect the malware within the Docker container and also on the file system produced by the container. And also we are able to keep a track on some vulnerabilities that may lead to a code execution outside of container. So this is where your application breaks out of container and tries to damage your physical host. Track on that as well. And speaking of Kubernetes, it will be added in a few releases. So we will support Kubernetes shortly as well. Okay, do you have more questions? Okay, thank you very much for being with us. It was really an amazing presentation, and I'm honestly surprised by the number of questions that we got. Very good questions, very interesting. This webinar is always available on demand, so you may view it and share it anytime you want. And on the final slide, there are contacts, so don't hesitate to contact us. Ask your questions. We will be happy to get in touch with you and understand how we can help each other. Again, I'm Pavel Pokrovsky. I'm Blockchain Security Team Manager at Kaspersky. And Ramy AlDamati, he's a Lead Solution Architect and Blockchain Influencer at Kaspersky. Again, thank you for being with us. Have a great day. Contact us. Thank you. Bye-bye.
Thank you, everybody.